Hello everyone. Welcome to another comprehensive explanation of a topic that is geometrical properties of circle. In this topic, this topic is useful for almost all grade 10 equivalent qualification, whether it is O levels, GCE, IGCSE, Edexcel, Pearson, you name it. So this topic is really requires critical thinking, and its properties are crucial for problem solving. Firstly, this video will have, in this video I will be explaining the prerequisite knowledge that you require to perform better in this topic. And this prerequisite knowledge involves this all. And then we will be looking at the properties of circle one by one, properties of circles one by one with examples, right? And then we will be solving the past year's questions, this and some of this, right, to give you the very deep explanation about the topic. And by the end of this video, you will be able to perform better, very better, inshallah, in this topic, right? So this is a very comprehensive explanation of this topic. So before that, I would request you to please subscribe, like, and share the video, so that I will remain motivated to make some more videos like that and make your life easier. So starting with this prerequisite knowledge. So this is a circle, you know that, and this is the center of the circle. Everyone knows that, right? And the distance from the center to any point on the circumference is called radius. And the point, if there is a straight line that has only one point of contact with the circumference of the circle, is called tangent. And a line segment that has two end points on the circumference is called chord of the circle. And if this chord passes through the center of the circle, this is called diameter. And we have 2 points. We have 2 points on the circumference of a circle, and this is a line, not a line segment, right? This is a line, right? So this is called secant. So I guess you can understand the difference between the chord and the secant, that secant is a line, your chord is a line segment. That means these 2 points are the end point. After B there is no line, before A there is no line. These A and B are the 2 end points of this line segment, right? So this is a short review about the circle. And we all know that triangle, if we are going to add 3 angles of the triangles, this must sum to 180, right? And the type of a triangle, isosceles triangle, you know that isosceles triangle is one in which 2 sides are equal and the angle opposite to these equal sides are equal, right? And if we use the very same property that sum of these 3 angles equals to 180, then this x plus x is 2x plus y is equals to 180. That means if I know any one angle in this isosceles triangle, I can find out the remaining, right? Let's say if I know y is, let's say, 100, right? So this is 100, that means 2x plus 100 is equals to 180. That means this 2x is equals to 80. That means this x is equals to 40, right? Similarly, if I know that if this is 40, so this should be 40, and 40 plus 40 makes 80, and 180 minus 80 is 100. So you need to make sure that if any one angle in isosceles triangle you know, right, you can find out the rest of the angles very easily. And this will often happen in this topic, right? The next is equilateral triangle in which all sides are equal and all angles are equal, right? So If all angles are equal, then this sums to 180, and then 3x is equals to 180. That means x should equals to 60 degree. Right angle triangle in which one angle is 90 degree, and these two should be complementary angles. Matlab they must sum to 90, right? And if you know one angle, let's say 30, then other angle should be 60 degree, right? And then there are some congruency tests. Sometimes you will have a question in the examination that require you to prove one triangle is congruent to the other, right? Congruent is a word that is a synonym of the word equal. How you can prove that two triangles are equal? Property number one is side. That means if there are two triangles, and if you can see that one side is equals to the other side, this side is equals to this side, and this side equals to this side. If you manage to prove that the three sides of one triangle are equal to the corresponding sides of the three triangles, then you can say that these two triangles are equal or congruent, right? The other property is side angle side. That means two sides are equal and they have equal included angle. This A in the middle is for a reason. That means if this angle is called included angle of the two sides, included angle, that is in between these two sides which are congruent, right? So if two sides are equal and they have equal included angle, then you can say that these two triangles are also congruent. Property number three, that two angles and one side. If two angles, we have here, we can find out this angle, right? It's 30 plus 80 is 110. And if 180 minus 110, that is equals to 70, that means this angle is 70. So one angle 70, second angle this 80 is equals to 80, and the side opposite to 70 degree is 10 millimeter, and side opposite to this 70 degree is also 10 millimeter. That means if two angles and one side are equal into triangles, then you can say that these triangles are also congruent, right? The fourth property is RHS. RHS means for a right angle triangle, if hypotenuse is equals to hypotenuse and any other side is equals to that side, that means these two triangles are also congruent, right? These were the conditions for congruency. And for similarity means what? They have a same shape, but they can be of different size. They can be of different size. So the first test for similarity, in order to prove that two triangles are similar, if you can manage to prove that two pair of angles are equal, that means this 30 is equals to 30 and this 50 is equals to 50. If two angles are equal, that means this is enough proof to say that triangle ABC is similar to triangle XZY. And you need to make sure that you have a proper order of the vertices that you have written. For example, angle A is 30, and what angle is 30 here? X. So A corresponds to X. Angle B is 50. So here angle Y is 50. So B corresponds to this Y. We need to write here Y, right? We need to write here Y. Y is written, let's say. And then Z. C, I don't know what angle C is, but if the two angles are equals, if I'm going to add them and subtract it from 180, it will become 100. it also becomes 100. So this C corresponds to Z. So that means C corresponds to Z. So this ABC is similar to triangle XYZ, right? So in short, if you can prove that two angles of one triangle are equal to two angles of the other triangles, then these two triangles are similar. This is how you prove similarity. The second example is similarity test is side, side, side. That says all three sides are proportional. Three ratios of the corresponding sides are equal. Ratios means if 6 divided by 3, 4 divided by 2, and 8 divided by 4, if they give the same answer, that we say that three ratios of the corresponding sides are equal, this is also an evidence to say that triangle DEF is similar to PQR, right? And the last property is a similarity test side angle side, right? So it says that if two sides are proportional, that is 6 divided by 3 and 10 divided by 5 is equals to the same ratio, that is 2, and they have equal included angle, then this is also a proof that two triangles, you can say that they are similar, right? So this is a prerequisite knowledge that you need to understand. One more thing that you should have a very clear idea about corresponding angles, alternate angles, vertical angles, angle at a point, all that. Let's have a quick review. If there are two sides which are parallel, so actually there are 8 angles that formed, right? Corresponding angles, and in these 8 angles, angle 1, angle 2, angle 7, angle 8, they are called exterior angles, and 3, 4, 5, 6 are called interior angles, right? So angle 1 and angle 5, they are corresponding angles, and they are equal here because the lines are parallel, right? If you can see why they are called corresponding angles, because one is exterior, one is interior, they are on the same side of this transversal. The third line that intersects these two parallel lines is called transversal. They are on the same side of transversal. One is exterior, one is interior, and they will be equal. So according to this definition, this angle 4 should equals to angle 8. They are also corresponding. Angle 2 equals to angle 6, right? Because one exterior, one interior on the same side of transversal. And angle 3 is equals to angle 7. Angle 3 is equals to angle 7. They're also corresponding angles. And alternate angles are that angle 4 is alternate to angle 6, right? And they are equal because the lines are parallel. And if you can understand the property of alternate angles, that angle 4 and angle 6, they are both interior and they both are on the opposite side of the transversal. The same property is proved by this angle 3 and angle 5, right? So they are alternate angles. Vertical angles, whenever two lines intersect, the two non-adjacent angles are vertical angles, and they are always equal, right? For example, this angle 1 equals angle 3, this angle 2 equals angle 4, angle 5 equals angle 7, and angle 6 equals angle 8. Angle at a point, at one point, the total angle should sum to 360, right? Angle of a straight line is 180. That means if you are going to add angle 1 and angle 2, they should equals to 180. They are also called supplementary angles. And angle 1 and angle 4, they also sums to 180. And some of interior angles are also supplementary, right? And we have a good reason for this to believe, because if angle 4, let's say, let me make it again, this is angle 1, this is angle 4, and angle 1 equals to angle 5, right? So if these two are equal and 1 plus 4 is 180. That means 4 plus 5 was also 180, right? Angle 4 and angle 5 should also sums to 180, right? So this was the prerequisite knowledge. You can take a snapshot in order to making the notes if you wish to, and you can also take a snapshot of these all properties to make your notes, right? I hope you get it. Now let's start understanding the geometrical properties of circle. We have two types, two categories, you may say that, of properties. One is symmetric and the other are angle properties. Symmetric property number one is about perpendicular bisector of chord. You see, if there is a line that is coming from the center, this property says if AM, this, equals to MB, if this happens, then OM should be perpendicular to AB. That means if you see that AM is equals to MB, let's say this is 3 centimeter, this is 3 centimeter, then you can put 90-degree here from your side, right? And vice versa of it is also true. That means if you see a line coming from the center makes 90-degree with the chord, that means it should bisect the chord. Bisect matlab? Bisect means it will divide the chord in two equal halves, right? So let's look at the question. See, this is example 1. We can see in this question that this is A and this is A. That means we can see the bisection. That means we can put the 90-degree here or there, wherever I want to, right? And if this line is 5, so I can apply Pythagoras theorem that hypotenuse square is equals to perpendicular square plus A square. That is 169 minus 25 is equals to A square. That is equals to 144 is equals to A square. That gives us A is equals to 12. And if I know that A is 12, I can work out this angle B by any formula I would like. Let's say if this is 13, then this is also 13, that is radius. So you can find out this angle by applying any trigonometric ratio. Let's say if I apply cos B is adjacent over hypotenuse, right? So this B should equals to cos inverse of 5 over 13. That, if you will calculate, it will be equal to 67.3 degree, right? Hope you get it. So let's look at the example number 2. So in this example, we can see that there is a 90-degree angle, right? So if there is a 90-degree angle, that means it will bisect the chord. Then this would be 6, this would be 6, and this would be radius, right? So on 5 and 6, I can apply the Pythagoras theorem to find out this radius, that this r square is equals to 5 square plus 6 square, 25 plus 36, and then r will be equals to root 61. And then we can find out this angle. If we know the radius is root 61, and we can see there is a 90-degree angle, so it will bisect the chord like 5 and 5 according to the property we have discussed recently. So we can find out easily that this is about adjacent over hypotenuse. This is cos f is equals to adjacent over root 61, right? So if you are going to find this out, this is cos inverse of 5 over root 61, which is equals to 50.19. I guess you got this property. Now look at the property number 2. This is about equal chords. Equal chords means if you see that there are two chords, AB and PQ, and if you see that if they are equal, then the distance of these chords from the center should be equal. That means this ON should equals to OM, right? That means equal chords are equidistant from centers, right? For example, if this AB is given 16 centimeter, let's say, and PQ is also given 16 centimeter, and if this is, let's say, 5 centimeter OM, then OM should also 5, right? That means equal chords are at the same distance from center. And remember, when I say distance from center, that means I'm talking about the perpendicular distance, right? So look at this example. If, and vice versa is also true, right? If we see that ON is equals to OM, if we see that they are equidistant from the centers, then we can easily assume that these two chords should be equal. So now look at this. These two chords, I can see that this sign and this sign, it indicates that these two chords are have equal distance from center. That means this A has no option but equals to 12, right? The length of these two chords should be same, right? So this A is 12. And we need to work out this angle. And if this angle is 90 degree, then for this B, there is no option, but this distance is also 90 degree, right? This angle is also 90 degree. Look at this example. Yes, we can see in this circle that these two chords are equidistant from center. That means this also equals to 22 because the distance from the centers are equal. And because this is bisected, right? So this X should be half of 22, that is 11 centimeter. And if this is 90 degree, then this should also 90 degree because distance from the center is the perpendicular distance, we know that. Symmetric property number 3, the tangent is perpendicular to the radius. When the relation between the tangent and the radial segment is always 90 degree, right? Tangent is always equals to, always perpendicular to the radius. Now look at this example. Example number 5. We need to work out angle PBA. That means this angle we need to find out, right? So we know that from the above example, if this is a tangent drawn as we can see, that means this angle is 90 degree, right? So how can we find out this angle? If you see that this angle is 33, I know that this is radius and this is radius. So this triangle APO is an isosceles triangle. That means this should also equals to 33. And if you add then 33 plus 33, it would be 66, and subtract it from 180, then 66 and subtract it from 180, 180 minus 66 is 114, right? So if this is a right angle triangle, if this is a right angle triangle, and I know that this is 90. So these two should be complementary, right? Sorry, I'm really sorry that this is 114, this is 114, right? And this is 66, right? So these two should be complementary. So 180, 90 minus 66, 90 minus 66, because these two angles should sum to 90. एक 90 हो गया तो बाकी दो का सम भी 90 होना चाहिए. So 90 minus 66 is 24. I hope it is clear. Now look at the example 6. We need to work out here angle COD. Angle COD. This is the angle that we need to find out. And this time we need to find out in terms of x. Means no numerical value is given in this question. And we need to work out it in terms of x. So how can we do that? Let me have a glass of water. Yes. So, first of all, if this is tangent and we can see that this is 90 degree and this angle is x, then this should be 90 minus x, right? Angle BOA is 90 minus x. And I can also figure out that this angle should equals to 180 minus this 90 minus x. So 180 minus 90 is 90 minus plus. So this is 90 plus x. And angle COD, if as you can see that about the symmetry, this is radius, these two lines are equal, these two lines are equal as indicated in the question. This is radius and this is radius and this point is common. So that means these two triangles are actually congruent. That means this 90 plus x, when divided by 2, it should give you this COD which is asked. So angle COD should be half of 90 plus x, right? So this is property number 3. Now look at the last property, last symmetric property, that is about equal tangents. That if there is a point outside the circle that we called external point, and if you draw two tangents from this, PA and PB, their length should be equal. And you need to understand one thing, that I know that tangent always make 90 degree with the radius, and if this is radius and this is radius, they are equal. And according to this property, that the length of these two tangents are equal according to this property, then the last line in these two triangles, that OP and OP is a common side for these two triangles, right? So that means we have two congruent triangles. I can say that triangle OPA is congruent to triangle OBP. Reason for that three sides, that radius is equals to radius, PA is equals to PB according to this property, and this line PO is common. So according to side property that I have discussed earlier, these two triangles should be congruent. That means you should be sure that this angle should equals to this angle, and this angle should equals to this angle, right? And this shape PAOB forms a kite, right? So now look at the questions. Example number 7. In example number 7, the length of PB is given 15. So for sure that this D should also 15 centimeter according to this property, right? The tangents are equal. Because we know that if you draw a tangent from the outside, you can draw two tangents from the outside. They should be equal in length. So this D has no option except that it should be equals to 15. And if this is 32, that means this should also equals to 32. And I know that radius and tangent are perpendicular to each other. That means the C should be equals to 90 minus 32. That is equals to what? 58. Right? I hope you got it. Let's look at this example. In this example, we need to find out angle G and angle H. What is given here is only one angle 35. Firstly, we know that radius is perpendicular to the tangent, right? So we can put 90 degree here. That means we can find out this angle, right? This is equals to 90 minus 35, right? Which is equals to 55 degree. So this angle is 55. So if this is 55, so this is also 55 because of the symmetry we have studied, right? So that means this angle is 100. This angle is 55 multiplied by 2, that is 100. And if you can see that this is radius and this is radius, that means we have triangle AOB as an isosceles triangle. That means if these two lengths are equal, then angle opposite to it are also equal. That means this is an isosceles triangle, this would be G. So I can use this logic that G plus 110 is equals to 180 degree. That means 2G is equals to 70. 180 minus 110 is 70, and G should equals to 35 degree. Now look at H. H is easy to find out. You know that radius is always perpendicular to the tangent. So this H, and if this G is 35, then this H should be 90 minus 35. 90 minus 35, which is 55. So this is all about what? This is all about the symmetric properties, 4 symmetric properties of circle. If you want to take a snapshot of this working, do take it. Because this video is a comprehensive video, so it will be a longer one, and I suggest you have a glass of water and then start looking at this video again. So now we have angle properties. So let me have 1, 2, because you can take a snapshot of it and you can take out its print or whatever and do the working on the paper along with the video. So that would be a good idea for practice, right? Now see, property number 1, that angle at the center is twice of the angle at circumference. You see, if this angle is let's say x, then this angle is 2x. And the reason for this is these two angles are facing the same arc, right? This is a condition. For example, this x is 30, then this 2x, this central angle should be the double of it. It should be 60 degree, right? So angle at the center is twice the angle at the circumference, twice of angle at the circumference, if they are subtended by the same arc. This is the condition, that same arc should be there, right? For example, if this is 40, then this A should equals to 40 times 2, double of it, that is 80, because they are subtended by the same arc. Clear? Look at example 10. We need to work out this angle G. I know that if these two sides are parallel, and this is G, then this is the alternate angles. This should all be G. And this is radius. This is also radius. So if this is G, then this should also be G. And if this is 70, then this angle, actually you can find out what? You can easily find out, because this angle is subtended by this arc. Angle at the center is 70. So this G should be half of it, right? So this should equals to 35, right? Or else you can find out by using the logic of isosceles triangle. But this example says that angle at the center is double of the angle at the circumference. So that means angle at the circumference is half of the angle what is on the center. So we can divide this 70 by 2 to get this G, right? I guess this is easy. So property number 2, that right angle in semicircle. This is not wrong to say that is the same as property 1, because I know that angle at the center is 180. And when you divide 180 by 2, so this should equals to 90. Or we can say if there is an angle that faces the diameter, so this should equals to 90 degree. That we say right angle in a semicircle, right? So look at this. We need to work out this angle C. So that is easy. How? Because if this is the diameter, that makes this 90, because this angle is facing the diameter, so this should equals to 90. And if you see that these three marks, this indicates that, let's say if this is point A and this is B, that means this triangle OAB is equilateral triangle and all the angles are equal. That means this angle should equals to 60. So if this is 90, this is 60, that means this is a right angle triangle in which these two angles are complementary. So this C should equals to 90 minus 60, which is 30. And let's apply the very same property to example number 12. Now see, we have a diameter here, which makes this 90, which makes this 90, right? And if this is D and this is 30, then this angle should be 60, right? And if this angle is 60 and they are subtended by the same arc, opposite to this is this arc, and opposite to this D is also the very same arc. So this D should equals to 60 degree, right? We don't need to make some more effort on this, right? So this is an easier example. Or was there any other approach? Yes, there can be, but that is the easiest one, I guess, right? So this was example 12. Let's come over property number 3, that angles in same segments are equal. I just applied this property here in this. So this is also easier if there are angles at the circumference, and if they are facing the same arc. So these all angles should be equal. That we say that angles subtended by the same arc are equal, right? Because they face the same arc. Look at this. We need to work out this x. If this is 50, which makes this angle 50 because they are alternate angles and the lines are parallel. So this 50 is subtended by this arc. So if you look at this x, this is also subtended by this arc. So x should clearly be 50, right? So come to example number 14. We need to work out this y. This is 68, which is subtended by this arc. So this is also subtended by the very same arc, right? So this angle should also be 68. So you just add them and subtract it from 180, you will find out y, right? So y plus 68 plus 100 should sum to 180. That y is equals to 180 minus 168. 10 minus 8 is 2. 9 minus 6 is 3. This is equals to 32. Oh, sorry, 12. 7 minus 6 is 12. Right? So, second last property. Property number 4. Angles in the opposite segments are supplementary. So, this is what we call cyclic quadrilateral. A quadrilateral which has all four vertices on the circumference of the circle, then angles in the opposite segments are supplementary. That means the sum of angle A and angle C is 180, and sum of angle B and angle D is also 180, right? Now see this example 15, how we apply that. We need to work out this angle ABC. You see, if this angle is given 65, so this angle should be equal to, oh, I did a horrible mistake here. Oh. Thanks for this function undo. So 180 minus 65 is this angle, right? So let me do it here. 180 minus 65 is 115. And if these two angles are supplementary, so you can subtract this 115 from 180 to get this B. That means this is equals to 65, right? So basically, this exterior angle of the cyclic quadrilateral is equals to the interior opposite angle, right? So, or you can follow the very same approach, that's whatever I did. So, 16. We need to work out this x. So, this x is subtended by this arc. Is there any other angle that is subtended by the same arc? Yes, x. And if this is 41, then this should also 41, because this 41 is subtended by this arc, right? 41. So this is 41. So, or you can think in this way that if this is 65, then this is also 65. Reason? Because this 65 is facing this arc. So this is also facing the very same arc. So this is 65. So now you can do one thing. This is a cyclic quadrilateral. Let's say this is A, this is B, this is C, this is D. So angle B and angle D, they are opposite angles in this cyclic quadrilateral, right? So their sum should equals to 180. That means x plus 65 plus 41 plus 27 should equals to 180. Then you can work out this x. You can work out this x, and this should equals to this should equals to 47. Right? Let me check this out again. 65 plus 41 plus 27 equals to 133. Subtracted from 180 is 47. Yes, correct. So, yes. And the last property, angles in alternate segments are equal. This is a tricky thing to understand. That angles in alternate segments, you can see in the diagram that these two angles are equal, right? This angle and these two angles are equal. What is the connection? Connection is written here. That angle between tangent and chord, that means this is tangent and this is chord. This is chord. Angle between tangent and chord at the point of contact is equal to the angle subtended by the chord. The angle that is subtended by the chord, that means that angle facing this chord, right? So these two are equal. So angle between the tangent and the chord is equal to the angle subtended by the chord, provided that this angle is on the circumference, right? So angle DAT is equals to angle ACD. I hope you got it. So this is called angles in alternate segments are equal. So look at this example. This is 60. Angle between this chord and tangent, right, is 60. So angle that is subtended by this chord is equal, that means this is 60. So you can use that y plus 60 plus 70 equals to 180, and then y is equals to 180 minus 60 minus 70. 180 minus 60 minus 70 is 50 degree, right? The last is this. This is angle between the chord and the tangent, and angle that is subtended by the chord is here. So this is also y. So again, you can use the property that angle sum of the in a triangle are supplementary. That means 180 minus 3 plus 1 is 4, 8 plus 4 is 12. 180 minus 124 is 56, right? So this is the explanation of every property, right? You can take a snapshot of this working if you want, right? So that's great. Now you can take a breath because the video is now getting longer. But of course, when I say a comprehensive video means you are starting from the beginning and you will become a master in this topic, right? Right. So this video is all about, the comprehensive video is all about that, right? So what we have covered so far, let's have a look. We have covered the prerequisite knowledge, right? We have covered the prerequisite knowledge that we require to perform better in this topic. And now we have seen all the properties that are involved in this topic, that is geometrical properties of circle. Now we are ready to solve some past papers question. You can pause the video and solve this question by yourself, right? And else I'll find out, I'll solve it myself, right? So, okay, before solving this, let me explain you something, that there is a thinking process. There is a thinking process that you should adopt in solving some critical questions. That the first thing is, whatever angle you need to find out, you first look that in this diagram, this angle is equal to what other angle that we can easily find out, right? So this helps us to find out this unknown, A. Well, there is another approach, that whatever the angle is given, you start finding out the rest of the angle from it. And you will ultimately come up to that angle that you need to actually find out in this question, right? Approach A is, whatever the angle you need to find out, you look at what other angle this required angle is equal to in this diagram, right? A. B, if let's say the diagram is very confusing, so what you start doing, whatever is the given angle, you start finding out the rest of the angles from this given angle. That will help you to come up that angle that you need to find out in this question, right? So let's see how it works. So the part A, angle CPR you need to find out. Let's say, and there is one more suggestion, that always read the description. Do not only look at the diagram and start solving. Do read the description, because this gives you a hint, right? In the diagram, the two circles intersect at point P and Q. Okay, we can see that these two circles intersect P and Q. The line AB is tangent. Okay, the word tangent, is important to us, because if AB is tangent to the circles at A and B, that means after reading this, you can put 90 degree here, you can put 90 degree here, right? Because of the word tangent, right? And the two circles at A and B, AD and BC, are the diameter. Okay, that is also a good point to note, that this is also a center of the circle, this is also the center of the circle, right? And whatever angle facing them, it should be 90. BD intersects the larger circle at R. BD is a straight line that intersect the larger circle at R, right? And DBC is 40. Okay, DBC is 40. We need to find out angle CPR. Now look at where is CPR. CPR is this angle that we need to find out. Now approach A, that look at what other angle this is equal to. So this angle that we need to find out is subtended by what arc? Subtended by this arc. This 40 is also subtended by this arc. So this angle should be 40, right? Because angle subtended by the same arc. So this is 40. The next angle that we need to find out is CQR. Where is that? CQR is this, is CQR. If you can see that this B, C, Q and R, it makes a cyclic quadrilateral, right? And we know that in cyclic quadrilateral the opposite angles are supplementary. So this angle Q should equals to 180 minus 40, that is equals to 140 degree, right? Because opposite angles in the cyclic quadrilaterals are supplementary, right? Angles in cyclic quadrilateral, opposite angles in cyclic quadrilateral. Third angle that they need to find us out is ABD. ABD is where? ABD is here. See, हमने यहाँ जब 90 बनाया था तो अब हमें help मिल रही है कि this should equals to 50, right? 90 minus 40 should equals to 50, right? This should equals to 50. And ADB is this angle. So you can easily figure out that this is a right angle triangle, right? Since if this is 50, then this should equals to 40, because these two angles are complementary. They should be complementary. So this is 90 minus 50, which is 40, right? I hope you got it. So you can again pause the video and try this question out. Let me have again, I don't know why I'm feeling very thirsty. Yes. So this diagram shows two circles, each with center O. Wow. Okay, there are two circles. Oh, sorry. Okay, there are two circles with center O, right? And A, B, C, D are the points on the circumference of a larger circle. Okay. E, F, G are the points on the circumference of a small circle. Okay. E, F, G are on the small circle, right? And lines AEOC, and FG intersects at 90 degree at X. Okay, this AEOC, that means this line, AEOC, this line, and FG intersect at 90 degree at X. That means I can put here, oh, this is too thick. And how I can adjust thickness? Yes, from here. This is oh, 90 degree, right? So GOX is y, okay. We need to find out what? GEO. So this is easy. This is easy. If you see that this triangle, this circle, right? This circle, this y is subtended by this arc. The angle that we need to find out is also subtended by this arc. So this GEX that we need to find out, GEO that we need to find out, should be 2y. Angle GEO, because angle 2y, right? Because now in this question, see, there are 2 marks for this question, right? And 2 marks are for that they are asking reasons for your answer. So when you write GEO is 2y, so the answer is incomplete because you have not given the reason. This is 2y. This is 2y because angle subtended, angle at the center, not 2y, sorry, y over 2. Because angle at the center is twice of the angle at circumference. So this is let me adjust thickness, y divided by 2, and you need to write the angle. The reason that angle at center is twice the angle at the circumference, right? So this is the reason. And GCX, that means this angle you need to find out. So how can we find out GCX? If this is tangent, that we know that this is 90 degree, right? And if this is y, then this should be 90 minus y, right? So what we can write here, that this part B, angle GCX is 90 minus y. There are reasons that radius is perpendicular to the tangent and complementary angles. Right? Radius perpendicular to the tangent, make this is a right angle triangle, make this a right angle triangle, and then these 2 angles should be complementary, right? Now thirdly, DAB, this is the angle that you need to find out, right? So you need to work out DAC first, and of course multiply this by 2. So how can we do that? The center is y, right? Okay, this is 2y. Then DAC, okay. If you look at this angle D, because this AC is the diameter, then this should be subtended by the 90 degree angle, right? And right angle in a semicircle. So you write ADC equals to 90 degree. And the reason for it, angle in a semicircle, right? ADC is 90, and if this is 90 minus y, so this angle and this angle should be complementary of each other, right? So if I'm going to subtract this from 90, I should get this because this is a right angle triangle. So 90 minus y is equals to y actually, because 90 minus 90 cancel, minus minus plus, this is y. So this angle DAC is y, and the angle they are asking is this one. So DAB is double of it by symmetry. That means 2y. Hope you got it. So you can take a snapshot if you want. Okay. Now you can again pause the video and solve this question. Solve this question. A, B, C, and D are the points on a semicircle with center O. Okay, I can see the center O. T, A, and TC are tangent to the circle. Okay. Whenever I see that there are tangents, that means I can do what? I can make a 90-degree angle here with radius and tangent, right? ATO is x, okay? ATO is x. So TDOB is a straight line. Okay, I can see that this is a straight line. Show the triangle OAT. Show the triangle OAT is congruent to triangle OCT. Okay, we need to prove the congruency. Now see, triangle OAT and triangle OCT. You see, angle TAO is equals to angle TCO because they both are perpendicular 90 degree. We already realized it, right, in advance that it should be 90. Right, and if you see that OT is in the triangle OAT and OT is in the triangle OCT, and OT and OT, they are common. And if you see this OA and you see OC, they should be equal, and the reason for them is they are radii of same circle, and the reason for this is radius is perpendicular to the tangent, right? You have to give reason. So this is in right angle triangle, you manage to prove hypotenuse and one other side equal. So that means you actually managed to prove according to the property that we have discussed, that this, if hypotenuse and one other side you manage to prove that they are equal, that means these two triangles are equal or congruent, right? So that means OAT is congruent to triangle OCT, and the reason for congruency is RHS, hypotenuse and side, right? Okay, now find in terms of x, giving your answer as simple as possible. AOT. We need to give the answer in terms of x. AOT. Where is AOT? AOT is here. So if this is x, this is, of course, AOT is 90 minus x, right? So let me change the color for part B. Angle AOT is 90 minus x. I do not need to give a reason for it because this is a 1 mark question. And then OAB is this. So if this is, I know that this is 90 minus x. That means this should be 180 minus 90 minus x. 180 minus 90 minus x. 180 minus 90 is 90 plus x. So this is 90 plus x, and these two angles should be equal. So I am going to subtract this 90 plus x from 180 because this is an isosceles triangle, and divided by 2 to get this angle. So this angle OAB, this is B part 2. Angle OAB, you can pick it short, equals to 180 minus 90 plus x divided by 2. So 180 minus 90 is 90 minus x divided by 2. And reflex ADC, reflex angle ADC. You know, ADC is where? Here. This is the angle. And reflex means greater than 180 and less than 360. This is the reflex ADC. Reflex angle ADC. Now, can we find out ADO? The answer is yes. ADO, let me change the color. This angle I know, ADO is should be the half of this angle, right? Half of this angle, because angle at the center is twice the angle at circumference. That means angle at the circumference is half of the angle what it is at the center. So 90 plus x divided by 2. So this angle should be, let me make it thin. So this angle is 90 plus x divided by 2, and when you multiply it with 2, so this would be this complete angle, that is 90 plus x. And when this 90 plus x, you subtract it from 180, you will find out this reflex angle, right? So this is 360 minus 90 plus x. Angle what? ADC is 360 minus 90 plus x. If you look at this again, this was angle 90 plus x. Why? Because AOT is 90 minus x. So 180 minus AOT. Oh, 90 plus x. Okay, 90 plus x divided by 2. Sorry. So 360 minus 90 is 270. Is 270 minus x. Achha, minus 2 times of this. Let me look at this again. The video becomes too long. I'm also getting confused with that. What we have done, we have proved it. Okay. The first answer is AOT. We find out AOT is 90 minus x, and that is correct. And AOB is 180 minus 90 minus x. So 180 minus 90 minus x is 90 plus x. And then this 90 plus x, I subtracted it from 180. Okay. And divided by 2. Okay. That's correct. Then ADC is this angle, that is 90 plus x divided by 2, correct? When I multiply this with 2, so this is 90 plus x, and when I subtract this from 180, sorry, 360, so this is 270 minus x, yes. So this is reflex 270 minus x. So that is the last question of this, not the last question of this video. Let's solve this one also. So 24. A, B, C, D, and E. I said this is not required that you watch this complete video in one go, so because that's a longer one. So you can give it a pause and watch it later, and you can solve it this question by yourself, right? So this is a question. Mm, 24. We are left with the last part. So if the radius of the circle is 6, okay, if the radius is 6, let me make it 10, and x is equals to 35, and this x is equals to 35, we need to work out bt, okay. So how can we work out bt? We can find out ot first. And how we can find out OT first? Because the radius, if the radius is 6, I'm going to make this triangle, highlight this triangle. I'll find out this OT. How? Because if this is 35 and this is 6 centimeter, I can find out this OT by opposite over hypotenuse by applying sine 35. By applying sine 35. Is opposite over hypotenuse, that is 6 over OT, and that OT is equals to 6 divided by sine 35 equals to 10.46. Then BT is OT plus this radius. OT plus radius, so 16.46, right? So this is it. So let's make it the last question of this video. You can pause the video and solve it by yourself first. Look at this. A, B, C, D, and E are the points on a circle with center O, and AD is the diameter of a circle at F, right? So AD is the diameter of the circle at F, right? F is a point of intersection of AD and CE. This is AD, this is AD, and this is CE. F is their point of intersection. And what is given? That angle ACE is 24. This angle is given 24. ADC is given 72. This is 72 degree. And we need to work out what? First, angle ADE. So where is ADE? ADE is this angle. So this is very easy. If you see that angle we need to find out is actually subtended by the arc AE, and we have another angle which is given that is subtended by the same arc. So this ADE should equals to 24. And CED, this is the angle that we need to find out. So CED is subtended by what? Subtended by this arc. So do you see any other angle that you can easily find out which is equals to this angle? Of course, this angle is subtended by the same arc. And can you find out this angle? The answer is yes, because if this AD is a diameter, that make this 90 degree, That means 90 minus 72 is equals to 18. So this angle is 18 degrees. So the angle CED is also equals to 18 degree, right? We do not need to give a reason because this is a 1 mark question, right? And until unless examiner says that write out the reason for your answer, we are not required to give a reason. So the third part is CFD. CFD. This is we need to find out. If you see, this is not the center. F is not the center. So how can we find this out? We can find out this angle by doing what? By adding 24 and 18 and subtract it from 180. So 18 plus 24, 2 plus 1, 3 plus 1, 4, 42 it is. And when you subtract it from 180, so 180 minus 42, 180 minus 42 is 138, right? And when you subtract this 138 from 180, because this is a straight line, and you know that angle of a straight line is 180 degree. So CFD is 180 minus 138, which is equals to 42. Right, so this CFD is 42. The next thing is ABC. Yeah, this angle we need to find out. So if you can see, we have a cyclic quadrilateral here, A, B, C, and D. And the opposite angles of a cyclic quadrilaterals are supplementary. So if you are going to subtract this 72 from 180, you will get this angle ABC. So this is also very easy. So that angle ABC is 180 minus 72 degrees, which is equals to 108. Right. Given that DC is 4.5, DC is 4.5 centimeter, calculate the diameter of the circle. So this is basic trigonometry. If you see, this angle is 18, opposite you know, you can easily apply opposite over hypotenuse, that is sine 18 is opposite, which is 4.5 centimeter, over the hypotenuse, which is AD in this case, that you need to find out, which means that this AD is 4.5 divided by sine 18, which is equals to 14.56, right? So 14.56. And DE, so you need to find out this DE. So how can you find out this DE? DE can be find out by using sine rule. If you see, this was 14.6. 14.56. Anyway, this DE you need to find out. This is 4.5. If you know this angle and that you know that is 18, opposite side opposite to it is given. If you can find out this angle, which is 90 minus 24, is 66. You can apply a sine rule to find out DE, because opposite to DE the angle you know, and opposite to 4.5 the angle you know. So you can apply the sine rule. This is part B. 1, and this is part 2. So DE over sine 66 is equals to 4.5 divided by sine 18. When you will work out this, 4.5 divided by sine 18 multiplied by sine 66, this is equals to 13.3 centimeter. Right, so you can take a snapshot if you want to. And I leave this last question to you that you should solve. A reference is given, you can look at the marking key because this video went too long. And believe me, this is an easier question. You can do it easily, right? So, gentlemen, this is all for the day. And this is a very long video, but this is, I believe, a very comprehensive explanation of this topic, geometrical properties of circle. I hope you like the video and stay tuned for the next video. Take care. Tata, Allah Hafiz.